volume. I don't think so in exam they'll give that much of time for you. I'm just asking efficiency. Later we'll plot PT graph, PV graph, other things. So what is 1, 2? Process 1, 2. Isochoric heating. How do you can say? Because PT graph, straight line passing through origin, should be isochoric, no? And in isochoric process, pressure temperature increases. Isochoric heating it is. So heat is absorbed. Isochoric it is. So I'll write it nearby. No, what about 2, 3? Isobaric pressure constant. So heat is absorbed. Isobaric heating. Isochoric heating. What about 3, 4? 3, 4 is what again? Isochoric process. So it is, in fact, it will be rejected. Some of you still the basic formulas, isochoric process, volume constant as pressure increases or temperature increases, it is isochoric heating, temperature, pressure decrease, isochoric cooling. That simple sentences also you are unable to remember. With poor memory, we can't do anything. There are no concepts. They're just the basic. What about 4.1? Isobaric cooling it is. Okay, now what we do? Shall we go for work done? Yes, you can calculate the work done. You can calculate the efficiency, anything. Okay, let's do one thing. We'll calculate work done. We are very sure net work done by the glass. Net work done. Let me discuss first that net work done. What is the net work done? W12, W23 plus W34, W41. W12 will be 0. Why 0? Isochoric process. W23 is what? Isobaric process. In isobaric, what is work done? Number of moles 3. NR T3 minus T2. Then W34 isochoric process. W41. Now what is W41? W41 should be again NR T1 minus T4. Straight away we'll get the work done. No, here you see there's no much information needed. 3 moles are there. 3 are T3. T3 is 2400 minus T2 800. 3 are T1 final minus initial, no? And T4 is how much? 1200. Okay, 16 into 3, 4800 R, 1100, 11 minus minus 3300 R. 1500 R. Okay, directly straight away we'll get the network done. What about the Q positive, Q negative? Q positive, Q negative. So already network done is what? So Q positive will calculate. Where all heat is absorbed? Q12 plus Q23. Monoatomic gas, number of moles, CV, T2 minus T1.
Sir, T1 is 400, sir.
T1 is 400. What I wrote 400 here only. This one.
Yes, sir, you wrote 100.
Okay, 800, 2400 it is. How much will get? 2400 answer. Okay.
Yes.
This? Yeah, now we'll go for it. This will be, what is the, in isochoric process, what is Q heat absorbed? NCV delta T, change in intensity. In isobaric process, what is heat absorbed? NCP delta T. what is the value? 3R by 2. Monoatomic gas, 3R by 2. T2 minus T1, 800 minus 400 plus 3 into 5R by 2. Okay, no, in the bracket T3 minus T2, 2400 minus 800. So 400, 400, 400, 200, 200 into this 1800 R 2400 minus 800, 1600, 1600 by 2, 800, 800 into 15. Anybody value?
12,000 or
12,000, huh?
yes.
Okay, this one. Yeah. So this will be 13,000, 12, 13, 13,800 R. Okay, so now what is the efficiency formula? Straight away, what is the efficiency? Net work done by Q positive. If you design and if you're engineer, if you design, will you retain job? You'll be thrown out, no? Look at the efficiency, very poor. Efficiency, in fact, very, very poor, that one. It's not a good thing. Of course, we know only temperature. What actually, sir, what actually you're doing? Some students have said, sir, what actually you're discussing? What I'm discussing, I'm having, what we are having? We are having in a cylinder, there'll be a piston. Okay, fine. This is, so initially, what is the pressure P1, volume V1, temperature T1. Then what I do, I'll supply Q1 amount of heat. Then what will happen to gas? The gas will undergo a process, isochoric process, volume constant. Fine. The pressure will increase. Volume will be there as it is. And this is T2. Will I agree this? This is what happening. Now I'm going to supply heat. So they should be like this. Huh? We have supplied an heat. Now again, I'm going to supply heat. On supplying heat, what happened? The gas isobaric process. Now volume will change, temperature change.